Alrighty, look at that. I remember the record button. I have forgotten it before, so if you don't see me click record, just holler at me because your classmates will appreciate it. Again, I make no warranties. Like, no, I'll do my best to record the sessions. But if something screws up, it screws up. Or if I forget, I forget. So, you know, you're all here in person. I don't know, I'm preaching to you, but you know, that's your best bet. Thank you. There's three of you who took the syllabus quiz. I got a couple questions about it, which is great. You guys get emails from Canvas when stuff shows up, and you're like, "What is this crap?" So I was going to tell you Monday. Sorry, I missed you. I took some NyQuil probably about like 5 in the morning because I wanted to actually get a little bit of sleep, and then slept through my alarm. And at 10:50, I woke up. My wife was like, "Don't you have class?" I was like, "So." I'm like about a 40-minute drive from here. So by the time I showered and got here, just would have had 5 minutes of class, and that seemed dumb. So apologies. Um, yeah, so I'm mostly better. Just don't get too close. The cough is still here, but the hot coffee seems to help that. So, and I think we'll be okay because we had a little extra time in here planned for loops. I think we had 2 weeks dedicated for loops. And usually after 3 sessions, you get pretty tired of me talking about loops. So I think it'll work out okay. Um, I just won't go today. Goodness. So we'll get into chapter 4 loops. So the chapter 4 section of Zybooks then we won't have due until the 29th here. You probably saw I didn't put scores in yet for chapter 1, 2, and 3. I had more than one person email me and say, hey, I got it late or I was having some technical trouble or something happened or I enrolled in the class late. Can I have more time? And instead of me going through and scoring a bunch of people and then having to re-add scores I'm just not going to put scores in until next Monday. And I'll do that for chapters 1, 2, and 3. So you all are welcome to take advantage of that. Get in as much as you did. If you didn't get it done yet, I won't put the scores in until Monday, what day is that? The 29th here. Uh, so I can actually, should I just officially change it here real quick for you then? These dates? No, that's not the right Monday. No, the 22nd. I'm sorry. I can't. The 29th will be for chapter 4. Let me put that in here. So here's chapter 4. And then that'll be Monday the 29th because we've got a little bit of time on that. I think I've put these all at 100 points to make it easy. Yeah, and I'll go ahead and change these deadlines. Why not? We can do that real quick. So we'll just do the 22nd for these. Um, and then I'll go and put the scores in for everybody. And this does include the Xi Labs. So if we go and look real quick, I can give you a snapshot here. The sales rep for Zybooks called me and was like, "Did all your students get the book? Because they're concerned they're not making enough money, or I mean, they're concerned you're not learning, obviously." Uh, so I was like, most of them got it. So yeah, so not quite as complete on chapter 3. So maybe this little extra time is helpful for several of you folks, which is fine here. Um, Not even 100% on chapter 1. I'm a little disappointed, but that's okay. It's your score. It's not my score. It is what it is. So the weights for these things, when you look at it, they give you like a certain number of points here. Like this was the 1 point here for that. Um, so the challenges and labs are worth more than the participation. Just the way it's all scored out here, right? Um, so that should work out okay for you here. Yeah. Most of these got done here. Okay, 75% of you got through. Um, yeah, we'll just go from there. So 2 weeks for chapter 4, or 2 weeks from Monday. Is that reasonable? Again, it's for your own benefit. You want to keep up with it because it's good practice. If you leave it all to the end, it's not beneficial, and then it just really feels like busy work. And ideally, it's good practice, that sort of thing. So, all right, let me fire up Visual Studio, and we can make a new project and start talking about loops. So loops are a lot of fun. There's a lot to it though. So it doesn't seem like there's a whole lot, but I promise it'll get more interesting as we go here. So we'll start with our while loops here, and then we'll get into for loops. We'll get into nested loops, which are my favorite here. We can do lots of fun things with nested loops. And then we'll look at some fancy keywords that I don't like in loops, but people use. I just don't like them because they confuse me. I get confused easily, and I'm a big fan of code should be readable and understandable, and you should be able to look at the code and understand what's happening without having to do mental gymnastics. And the break and continue keywords make you have to do a little bit of gymnastics here. We'll look at scope, and then enumerations is fun. That's a fancy word here. We'll look at all those as we go. Okay. All right. So let me start up a new project here, and I'll make sure I put it in the course repository. Right. Pick the location here. So I'm going to do a console app that gives me the starter code. I like that. You can start with empty. That's okay too. I don't want to put it in the project 0 folder. Right. That was my demo showing you how you would go and clone the repository, make your project in that folder so Git can track it. Right. I'm just going to put it in my main course repository. If you're never sure, just click your three dots and go browse. Right. That's okay too. I like to copy paste. I would like to click less here. It makes me happy usually. We call this week 4 loops. Are we still in week 3? This is the end of week 3. I really don't know what day it is here. I'm sorry. It's the cold Mets. uh, you not know either. Is it 3 or 4? Yeah. Trying to start counting on Wednesdays always confuses me. So I do this as week 1, this is week 2, this is week 3. So okay, we are week 4, sort of. Yeah, it's like just a day. It was weird. Okay, I'll call it week 4 loops. Just hopefully that keeps it a little easier to view. Like things get alpha sorted, so if you put week and then a number here, it should sort nicely. Hopefully it works out like that. All right, and then we'll create that project. We look at random numbers yet? No? No random numbers? Okay, well, it'll be fun. We'll do some random numbers in a minute then, because this makes our demo much more interesting. Again, I like the using namespace standard. If someone tells you not to use it, just smile and nod, but I'm going to keep using it because I don't like typing a bunch of stuff. And then for some reason, I really like these endls instead of the \ns. Again, I think it's just a little more visually appealing, is all. Makes no difference whatsoever here. Supposedly, this will work differently on different operating systems because some operating systems like a return character and a new line character. Some just like the new line character. I would have to go Google it. I don't think it makes any difference for our purposes. So make sure we get a little hello world. Always good to start with something. And then if I fire up my GitHub desktop client, I can see if it's tracking new files here. I got it in the right spot here. I go make sure I find the right folder or my repository here. I got a couple. Yeah, and I see my solution file, my VCX proj file, my CPP file. That's the important one. Right. At least have that one. The rest of the project files make it nice and easy so you can open it later, which is handy. At least have this one here. I'm tracking. Life is good here. I can make a commit. Why not? Before started. And then we'll push. So push, right? It manually syncs to the cloud. There is no automatic syncing here. It's not like your Google Docs that as you type it saves, which you can, if we think through enough here, that probably makes sense. You don't want your code to be changing on the fly because as we're typing, it's not even going to run, right? You got to get to a point where it's runnable here. All right. So some random numbers here. If you want to pick a random number, we get to use this rand function from the library, which is really cool. So it built in lets us generate a random number. So we'll have I don't know, we'll call this the lucky number here, equals, so it's rand and then a set of parentheses. Now, rand does some weird stuff to start with here. It should give me better, do I have to search online, really? I want the whole definition. No? Okay. All right, that's lame. We can just run it here and see instead of waiting for some output here. Here's random. C++.com, my reference here, generates a random number between 0 and the random max, which is some sort of big number depending on what's in your C standard library. This can vary. I don't think it's changed very often at all here. I wouldn't worry too much about it. But essentially, 0 to a really big number, probably about 2 billion or something, is my guess here. We could look up what random max is, right? Oh, goodness. Why are they ad supported here? At least 32,000 here, depending on how they've implemented it. That's helpful. So, some random number. So if you want a specific range of numbers here, we got to do some quick arithmetic, right? And they had some examples here with the modulus operator. That's one of my favorites here. That's the integer remainder of division, right? So if you take a random number, mod 100, you're going to get something between 0 and 99. Right? So if you want a number 1 to 100, you mod by 100 and then you add 1. Right? It gets you a number 1 to 100, which is nice. So if we want to pick a random number 1 to 100, we'll do a random number, mod 100, plus 1. You're welcome to add parentheses around modulus if you want. It's not going to hurt anything, but it has the same level of precedence as division. So we know that it will do the division first and then add 1, right? You all have, at least in calculus, so I think you can do order of operations by now. So we got a random number, and then we want to ask the user to guess it, right? So we can see out, guess a number 1 to 100. And then we can get the, I don't know, a guess, and we can see into the guess here. Right, now we can see, did they guess the number, right? They're either guessed the number, they were too high, or they were too low, right? So we can say, hey, if my guess is equal to the lucky number, we can see out, you guessed it. And then line. Now, else if, you probably don't need the else here, right? Because we're going to check, hey, if the guess is, you want to go less than or greater than first? Look for too low or too high.
Less than.
Less than, okay. So the guess is less than the lucky number, right? Because they are exclusive just because you can't be equal to and you can't be less than. We don't technically need the else here, but it's a, it's fine. One of these three things will happen, and then it's ever so slightly faster. Not that it's going to make any difference at all for us, but if we were to play this like a billion times, you would save, like 1 second or something ridiculous here. But again, this is probably better here to have it chained together with the if, else if here. So we can say, you're too low, and then line. And then if you didn't match and you weren't less than, really this could just be an else. We don't need an if saying your guess is greater than, because we've chained them together. If we had 3 separate ifs, then we would have to be guess is greater than if we weren't using our else clauses. Right? Either way is okay. It'll get the same job done here. So it's really just a style preference here. We'll say too high at this point here. Now, this is going to be kind of tough here for us to guess the number 1 to 100 and get it right the first try here. Well, let's try it anyway. What number should we guess?
72.
72. Oh, I typed 73. Too high. Oh, and we still have hello world. So this is not very interesting or very useful here. It'd be nice if we could play it again and play it again and play it again and play it again and, until we guessed it right. And I think I mentioned my rule of thumb before, but I like saying it often here. If you have the same code more than once, you should feel bad about yourself. It's a pretty good rule of thumb here. We don't want to have to type the same thing out more than once. We don't even want to have to copy paste it, right? Because, as we're going to learn today, there are better ways to do it. We don't need to copy paste this code 5 times and have you guess and check and guess and check and guess and check 5 times. That's really tedious. So what we get to do is we get to use a loop. We can tell the computer, do it again, 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 until something is true or false. Right? We use these Boolean expressions, that's our fancy technical term. Something is true or false to say if or else. Or if, elif, else if, else if, whatever. Here we have a Boolean expression. What we get to do is we get to make a Boolean expression that says, keep on running this code until it is true or false here. So we get a while loop. So instead of doing it one at a time, we're going to say while my guess here. Now, with a while loop, this one runs if the condition is true. Okay, so it runs if the condition is true. So we only want to run if it's true here. So what do we want to have happen? What do we need to be true here if we want this code to run? Well, we want to not be equal to the lucky number. If you guess the lucky number, you don't need to guess again. Right? So we're going to flip it here. So we're going to say, okay, if it's not the lucky number, and now I can just take this bit here and slide it in. I just cut and paste, right? Control X, Control V, cut and paste. So if you're not the lucky number, you were either too low or you're too high. You could not have been the lucky number. This block of code will not run if this is not true. And it's only not true if it is the lucky number, right? We got a little bit of a double negative there. If it's not the lucky number, right? Then it doesn't run. I know that sounds ridiculous, right? But the while loop runs if this is true. So if you guessed not the lucky number, we're back in our loop here, and we're probably going to tell you, hey, guess again, right? So guess again. And I don't know, do we need the same prompt here? We don't need to redeclare int for guess, right? We already told the computer we have an integer for guess, right? So we just need to give some prompt and take some input, right? And then I get to the end of my curly brace, and we come back to this condition check. So it runs if it's true, and we get to the end here, and it says go back and check the condition. Okay, we go back up to the top, the condition. If it's not the lucky number, run again. 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 It will run forever here. So you want to be careful that your condition here has a chance to change. If we never took any more input here, we would just be stuck in a loop forever, right? If we typoed and had some sort of a logical error in our code, this will just run infinitely, right? If I take out that input here, we'll watch it run forever. It's very exciting here. There's build errors. Oh, goodness. Oh, because I cut and paste my if block here. So I don't even need the if here because the only way for this to stop running is when this is not true. And if it's not true, then you did guess it. So I can get rid of that if here. Now we'll run, and we'll have an infinite loop if we don't guess it right the first time. What should we guess?
69.
69? Too high. Too high. Too high. Too high. Guess again. Too high. Guess again. Too high. Guess again. Too high. Guess again. This is very exciting, right? If we forgot something here, like the prompt, we're stuck forever. So like Control C, we'll kill that here. Or you can just close the window or hit the stop in your debugger here. You got a couple options. But we want to see and guess here. So eventually now we should be able to guess the lucky number, right? What should we guess? You all know how to do this the smart way, right? You start in the middle.
50.
Yeah, 50. All right, start in the middle. Too high. All right, so split the difference. If that was too high, go between 0 or 1 to 50. That was too low. All right, between that is like 37. That was too low, like what, 44. That was too high. I don't know, 40 is too low, 42. Hey, we got it, 42. And our program finishes. Eventually that became true. I'm sorry, the not equals the lucky number became false because it was the lucky number, and the loop is able to stop. Now, that doesn't stop your users from being stupid and just one, 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 one. But there's at least a chance the user is not going to be dumb, and the program will stop eventually, right? Right? We can't control what they're going to give us, but they have the opportunity to get out of this loop eventually here, right? You can click the X to close it. You can come up and stop. And anyway, I'm going to go out of here. So this is our first loop here. It's a while loop. If it's true, it runs. So it's possible your while loop never runs, right? If I put a breakpoint in here, right, we get to pause the execution of our program. So the debugger is your favorite tool because this lets you see behind the scenes. And I can see, hey, the lucky number is 42. Right? So I see what the lucky number is. Okay, awesome. So when I go, I'm going to continue on. Now it will prompt me here. We guess the number 42. My while loop never ran because I got the number the first time. So it's a pre-test loop. It tests to see if it's true. If it's true, it runs. Right? So it might not run automatically for us here. Oh, it's 42? Is it 42 every time? 42 every time. How exciting. So random is not actually all that random here. So what we want to do here to get a more random looking number here. Now, the reason why it's not random is because there's just code behind the scenes that says generate a random number. And if you've learned anything about code so far, you know it does the exact same thing every single time. So every time we ask for a random number, we get the same sequence of random numbers. These are pseudo-random numbers. They're kind of random looking here. But we'll get the same sequence. So if we want to change that, we're going to use srand here, which stands for seed random. So it says, here's a seed value that you're going to use behind the scenes to generate your pseudo-random numbers. And if you give it a different seed value each time, it'll look like a different series of random numbers each time. Okay, and then what do we have to do? I think we give it like time or something silly here. My goodness, I'm just going to go Google it. C++, and I think it's with time. Yeah, okay, the ctime library, that's what it is here. So we have to include ctime here. And then we should be able to ask for time. And I think we give it a 0. Is that right? Yeah, srand of time of 0. Look, seed's a random number generated with the current time. What that does for us is every time I hit run, it's probably a different time than the last time I hit run, like the clock time. Just some number of seconds have gone by, right? So it will look different every time for me now that I've seeded it here. And I suppose I should be good here and cite my source because I forgot here. Bing. Look at that. I have now cited my source. Academia is happy with me here. And I need my semicolon. So now it won't always be 42 here. And if you're going to cite some source, you got some code from somewhere that's not yours, that's all you have to do. Just drop me a note. This is where you got it from. Right? I'm perfectly happy with that. People get paid a lot of money in the industry to use other people's code for some pieces, right? They don't. They still have to do some of the work here, right? If anybody could just copy paste code, we wouldn't pay software engineers a lot of money, right? I think that makes sense. You need some sort of skills somewhere to understand what you're doing. Did you ever hear the silly story about some mechanic who had to like fix some machinery at some place here? It's like this really old guy. He's been at the shop for years and years and years, and he's been repairing stuff forever. And he retires, and then the machine breaks, and they don't know how to fix it. The new guy has no idea what he's doing, and they call him in, and he like walks around and he takes a hammer out and hits something, and he gives him a $1,000 bill. They're like, really, it's $1,000 to hit a thing with a hammer? He's like, oh, you want the itemized bill? $1 for the hammer strike, $999 for the expertise to know where to hit. Right? Knowing a couple things here is useful, right? That's why we become good developers because we know a few things here, right? So now it won't be 42, right? I took out my breakpoints, right? Is it running? There it is. Now let's guess a number. 50 is too low. Oh, it's not 42 anymore. Now it looks different, right? 75 is too low. Ooh, 87 is too high. Okay, so like 80, I don't know. Too low, 84. Hey, it's 84. And when I run it again, it's probably not going to be 84. 84 was too high. So now it looks random, right? And yay, it's kind of boring. We probably don't want to play this more than a few times here. This only entertains my kids for a few minutes now. Um, and they think typing into that black box is terrible. Sadly, all this class we're going to type into a black box here, the console, and then all of next class you're going to type into a console here. We don't get to any interesting graphical user interface applications until you get to your language electives here. And then we get to do some fun stuff in Java or Python or C Sharp and have buttons and things you can click on. It gets to be a lot of fun. Um, I don't know. I find them much more entertaining. Most people do. I don't know the last time any of you used a console-based application. Anybody? Yeah. All right. We got one taker for a console-based application. You're ahead of the curve. All right. Uh, they are very useful though. Like it's not unused. Lots of tools are console based. We write a lot of scripts and development tools and other things and shortcuts and things that'll be console based because you don't need the bells and whistles and the buttons to click on. So it'll be fun. All right. So that's our while loop. So it runs while it's true. Now, other things you might do with while loops, right? So I don't know, we'll put that, move our next code to the top here. We can even commit here. So here's our guess a number. Guess a number game, right? Why not make a commit here? Right. Now, if we wanted to make this even fancier, we could ask the user how high of a number they want to guess. Right? It doesn't have to be 100. We could get some input, and if you want to guess 1 to a million, because you're terribly bored here in your science class or something, you guess a number 1 to a million. Sure, and that could all be flexible, right? We just all the logic here is exactly the same. Is just what number we mod by, and what number is in our prompt, and those things are easy to change, right, with a variable. So use your imagination if you want to have more fun with it. But other things we could do with a while loop here are something like, do you want to play again? Do you want to run this again here? Right, so we can have some sort of input here. So why not a char for play again? Now, what I'm going to do is I'm going to start this as a y here because I'm going to make this my loop. So while play again is equal to a y, I want my loop to run. So by starting at something that I know will make the while loop true, I know my loop's going to run at least once, right? And then eventually at the end of my loop here, I'll ask them, do you want to play again? Play again, and then I'm going to suggest here, right, a, a y or an n, right? So like tell them y/n, and hopefully you'll get the right input here, right? We're telling them please enter one of these characters. Who knows what they're going to type in? But if they give me a y, we'll play again. Anything else, right, they're not going to play again here. Um, so we could take all of this here then and reseed it and put it inside of it. Do you want to play again or not? Right? So we get a loop inside of a loop. It works. So guess number 50 is too high, 25 too low, 37, 42, 46. Hey, we guessed it. Do you want to play again? Uh-oh. I did not input to play again. I put the prompt here, but it didn't actually ask them here. We're stuck in an infinite loop. We were playing forever. Oops. So we should CN on play again, right? Play again. All right. Now it'll actually ask you here. And, this is kind of getting a little tedious here. Let's guess a number 1 to 10. We'll make our life a little bit easier here, make it faster. All right, so guess a number 1 to 10. 5, 7, 6. Do you want to play again? Yes. All right, is it 6? Oh, we guessed it. Okay. Play again, yes. 6. Oh, we guessed it. Uh-oh. It's not changing here. That's a bummer. It looks like it should be seeding it again here. Why is it not reseeding? I'm sad it's not reseeding here. That's okay. It's not worth fixing right now. We'll come back to that later. It'll just take some more Googling here. Really should have. Oh, okay. All we have to do is move this out. We're going to seed it one time here because the next time you ask for a random number, you'll get another random number here. And that'll make life easier. Right, one more time to make sure it works. Look at that. I was able to fix it without a Google, I think. 5, 7, 8, 9, 10. Hey, we guessed it. Play again. Is it 10? It's not 10. Hooray, we did it. 7, 6. Okay, life is good. So the next random number that shows up here, right? All right. So all of this then is a loop inside of another loop, right? We can do that. You can have loops inside of loops inside of loops here. But these sort of, do you want to do something again? It's pretty common here. Other sorts of fun things we can do with our loops then. Here's our, what is this, an infinite play again-able? Play againable? That's probably a word, right? It is now. Right. Other things we might want to do here. It's a little bit annoying if I don't know if they're going to give me a Y or an N, right? So if I have some sort of valid input here, I can put you in a loop and make sure you don't get out of the loop until you gave me the thing I want here, right? And actually, let's do it here. Why not? So let's we're going to say while play again. Oh, so we're going to input play again. Do you want to play again here? Uh, and then while my play again does not equal a Y, or play again does not equal a no. I'm sorry, and. Sorry, we want and. If it's not a Y and it's not an N, it's wrong. If it is a Y, then this is false, false, and true. The whole thing is false. My while loop doesn't run. So I'm only going to make my loop run if it's not Y and it's not N. So if it's not valid here, we're going to tell them, hey, that wasn't valid. Or I don't know, enter only Y or N. Sure, we'll do another end line and ask, do you want to play again? So hey, only a Y or an N is valid here. And then ask them, do you want to play again? And input again. So they can't get out of this loop until they've given me just a Y or just an N. Let's try it and see. 5 is too low, 7, 9, 10. All right, 10 again. Do you want to play again? Yes. Oh, shoot. All right. If you just, so when you ask for just a character here, it takes the first letter. So I typed in more than one letter. That's my bad here. Let's try that again. So 10 was too high, 5 is too high, 2. All right, do we play again? Like A, enter only Y or N. You want to play again? B, C, D, E, right? F, N. Game over. Sure. Right, we did pretty good here. Um, so now you can't get out of this input here until we've validated it. So this is an input validation loop. So if I know what our valid options are, I'm keeping the user here until it's valid. Right? Works really nice. Now the problem is if you've got like 10 things that are valid options, this clause gets pretty long here. And that's unfortunate. We just don't really have a better way to do it yet. We'll get to better ways eventually. We just don't know any yet. So if a Y was valid, a N was valid, or a P was valid, and the Q was valid, I don't know, whatever we had here, it'd be a long list, but we could do that, right? And they can't get out of it here. So let's ask the user to guess a number here. Let's do that here. Um, oh, so this is why comments are stupid. I just did it to myself here, right? I had my comment documenting how I looked up srand here. But then I moved the code and I didn't move the comment. I swear, I'm just in the habit of ignoring comments. So now my comment lies because it's not attached to the code it's supposed to be commenting, right? So again, this is why comments are stupid. Uh, if someone else tells you to put comments in, just smile and nod. It's not the end of the world. I don't care, right? That's fine. If they want to give you points for it, you can probably put the comments in. It's not hard, right? The hard part's the code part. All right. Um, so now I move my comment here. So if we want to ask them, um, how high of a number do you want to guess? The number you want to guess, and then we can input, I don't know, a int for max guess or max number, and then we can see in on max number. Now I want to validate and make sure they gave me something good here. So if you give me a negative number, we probably have a problem, right? Because all of our code here, it might actually work if you give me a negative number. I'm trying to think here. No, because we can't mod by a negative number. That's the problem. We won't be able to modulus by a negative number. So it has to be positive, non-zero, right? So we can check, hey, while my max number is less than or equal to 0, change it, like you did it wrong, do it again here. We don't need to redeclare max number, and then we can tell them cout must be greater than 0, right? How high of a number we want to guess. So we can do a validation loop on numeric things, right? Hey, less than or equal to 0 is invalid, right? So we're defining the invalid, right? So an invalid range check for validation loop, right? If we wanted to put a max of like a million and say you should not be guessing numbers higher than a million because you're just wasting your time, we could have if it's less than 0 or it's greater than a million. So in this case, right, it is this way wrong or this way wrong, right? We could have that, right? Or max number greater than a million. 1, 2, 3, 1, 2, 3. So greater than 0 and less than 1 million, right? Whatever range we want here is okay. We can define the rules here. So now we're going to ask them here. Oh, I've got to fix one more thing here. Sorry. So it's not guess a number 1 to 10. It's guess a number 1 to max number, and then a colon. I guess the end line is kind of silly at that point, but that's okay. All right, let's try that. There it is. So how high of a number do you want to guess? -1. Must be greater than 0, less than a million. Let's try a billion. Must be less than a million. Okay, so the bounds checking seems to be working, right? I wrote some code. I want to make sure it does what I intended it to do, so I have to test it, right? Any code that's worth writing is worth testing, because if you don't care if it works right, why did you write it in the first place? If you're going to accept garbage, don't write it. It's not helpful, right? You shouldn't be making garbage, okay? I'll have a number. What about 50? Okay, guess a number 1 to 50. Oh, we're missing a space here. So Xylabs would mark us down here because we don't have a space after our dash, right? We should go fix it. We'll get in the habit of being accurate. So there's our extra space. All right. Then we'll go back and try it again. So, all right, guess a number 1 to 50. 25, it's too low. 40, it's too low. 45, it's too high. 42, too low. 43. Hey, do you want to play again? Yeah, let's play again. How high of a number do you want to guess? Let's guess 1 to 5 now. All right, guess number 1 to 5. 3, 2. Hey, we guessed it. You want to play again? A. Only wire and N. Right? Our validation loops are checking here. So no, we don't want to play again. Game over. Please stop. Right? So this is our validation loop for characters are not a valid option. Right? So this one, if it's not a valid option, we want it to run. This one, so this one was using ands, right? Because it has to not be any one of them here. Where this one was using ors, because it was this low on this side or too high on this side. Right? It can't be both. You can't and there. So those logical operators, they take a little bit of time. It takes some puzzling through. Oh, am I using an and? Am I using an or? What do I need to do here? And just like it did with our if blocks, we do it with our whiles. Right? We need to kind of think through and make sure it makes sense which one that we're using here. Okay? So we got while loops for our condition here. inside of a while loop for play again. We're validating that input here. Right? We can do all sorts of fun things with while loops. We've done a couple so far, right? So what does this commit do? So look, hey, we moved this line here, right? Red means removed, green means added, right? So this is now allows for setting the max number. And it's cool. It shows you at the line level what changed, right? Oh, we also have a play again. Oops. And play again, right? And I can push. We'll put that out there. Now, another cool thing I want to show you just because it's a fun feature here. If you go and take a look at that file here, there's an option called blame. Goodness, this one here. I can never remember where they put it. So blame will show you which commit changed what line in the file. And you can see how long ago it changed. But now the history on this one's not very interesting. But when it comes to bigger projects and things, you can like go look at a file like, oh, this part of the file hasn't changed in 3 months. That's probably not a problem if I'm tracking down some sort of bug that someone reported. Oh, it's not doing what it's supposed to do here. This part of the file changed last week. Oh, maybe I want to focus on that, right, when we're tracking down bugs that get introduced. So Git also adds those other fun features here. You can see what changed when, which is really nice here. Um, so that's just a fun feature there. And then again, I've got all my code out here. You can see it. Look, I've weeks. I didn't name the weeks here. This one was loops. This was branching. We could go rename them here, but that's probably a hassle as we go. All right. So we got our while loops. Feeling okay with while loops? All right, ready for something completely different then? All right, well, we'll do more. So that was our while loops. So the other kind of loop we can do that's similar to a while loop, but I hate them for purely there's one character, and that's the entire reason I hate them here, is called a do loop. So remember, we called these ones pre-test loops. They tested first before they run here. Now we're going to do a loop that runs at least once and then might repeat itself. That's a do loop here. So we can say do here. Actually, I want to leave my random up at the top here. Sorry, do that one here. So we're going to do at least once here, and then a do loop ends with a while what here. So we want to run at least once while what's true. I kind of like the play again idea here, but we're already using that one here. What should we do? While we'll say, how about a char for more or equals y. Now you don't have to set this char if you use the do loop. So that's some people like that. Or equals y. And then you put a semicolon here. This semicolon is really the entire reason I hate do loops and I never use them. I spent several hours as an undergrad troubleshooting my code one time because I didn't have a semicolon here, and it drove me bonkers. And ever since then, I've hated do loops. I never use them. That's my story. So it is nice you don't have to set the value of more because we can set it inside the loop. While with the play again loop here, excuse me, I have to sneeze. Maybe.
So
I,
worst.
I've got the genetic thing where if I look at lights, it usually makes me sneeze, but it's not working. I never realized it was genetic. That's crazy. There's a fancy word for it. What is it? Looking at lights makes you sneeze. Hang. Sneeze. Name. What is it called? Photonic sneeze reflex. 11 to 35% of the population are affected by that. Look at that. I'm rare. I knew it. I knew it. I'm special. My mom always told me I was special. So for this loop to work, you have to give play again a starting value, right? Because I've made it run at least once. With the do loop, it's going to run at least once, and I can just set it inside here. We can like see out, hey, do you want to play again? You want more? And again, we should probably prompt them a Y or an at here, this sort of thing. And an end line here, and then cin on more. Okay, so we'll run it again if you want to do more, or you could even use this as a validation loop, right? Go get some input here, and while it's not valid, keep on going here, right? Um, so okay, let's do it as a validation loop. And so it is not y, and more is not equal to n here. we'll keep on asking y or n. Now, this gets weird because now I don't have a chance to give them a message they did it wrong. I'm only giving them the same prompt because I can't tell them they did it wrong here inside the loop because it would tell them at the first time. So it's got some downsides, it's got some upsides here, but we can then use this because I know it runs once. I don't have to define more outside, right? I can have the prompt once. So some people like this here. So runs, this is a post-test loop, runs at least once here. Then it might run again, right? So if you want this for your validation loop, great. You can do it this way here. That's okay. Let's see how we're doing here. While loops. Do they even have do? I don't even see the do loop in here. I know they must have it in here. Do loop, do while loop. Do loop not found. Do while loop. Feel like something's wrong here. Do while loop. Ah, it's in it's chapter 16, additional material. Why didn't they put that in with loops? Okay. That's fine. We've talked about it. You don't have to go to the additional material section. That's okay. Just want to make sure I didn't miss anything there. It is fun to have a textbook you can search. That's kind of a neat feature. Why is it not even running? There we go. Right, so while loops, do loops. The other kind of loop we can look at is a for loop, which is a lot of fun. So now these get different, and that's okay. So while the do loop and the while loop run while a condition is true, a for loop technically does as well, but that's not really what we use it for. A for loop is usually if we want to run something a set number of times. So with for loop, we get three things. So we get to initialize a value, we get to test a value, we get to increment a value. So we're going to say for, and then a set of parentheses. And here's where we get the three things. So we might say int number equals 0. Right? We are initializing a value that exists for the purpose of this loop. Right? So number exists for the purpose of this loop. What's my test here? I want to say, hey, my number is less than 10. And I'm going to increment. I'm going to take number plus plus. Add 1 to number. Okay? So it initializes, it has the test, and then it increments my value. Or it could decrement, right? This is like change. Usually we increment here. It doesn't have to, but most of the time you see plus plus. That's pretty common here. And we get a see out number. And in that line. Very exciting loop here. This will print out what? What does it print out first? 0. And then this happens. And then a 1 and a 2 and a 3. And what number does it end with? 9. Yeah, because 9 is less than 10. When it becomes 10, it doesn't run anymore. Right? So this is essentially like the while condition here, test, right? Imagine, think of that as like your while condition here, like a while. I don't know if that makes any sense here. We'll just say while here, right? So we could repeat this here. We could say int number equals 0 while number is less than 10. See out number plus plus, and a deadline, right? This is identical to the for loop, but it took 5 lines of code instead of 3. Obviously 3 is better than 5, right? Less code is not always better. Some people think it is, but again, readability should be the highest priority. For loops are going to be a little weird for a little while, but we'll get used to them. Everybody uses for loops all the time because it saves you, in line here. And the other nice thing is it's hard to forget the increment, where with a while loop, if you have a bunch of code there, like the first time and we forgot the input here, like it's possible to have an infinite loop because we screwed up, because we forgot to do the increment here. Right? It's harder to forget it with a for loop. So it's a little bit safer to use because we know, hey, I'm going to do it this many times right off the bat here. So I want it 10 times. But both ways, we get the same number 0 to 9 printed out. Right? Here's 0 to 9 with the for loop. Here's 0 to 9 with the while loop. We'll even add that in here, right? Let's see out. Let's print 0 to 9 with the for loop. Right? Why not put that in our code here instead of a comment? Let's print 0 to 9 with a do or a while loop. Should we also do it with a do loop just for fun? Why not? Let's practice a do loop here. So let's say int number right? We don't need to set a value first. We're going to do, and now while my number is less than 10, semicolon, semicolon, let's see out. Hmm. Well, I kind of need to start it with a value, right? Because I'm not inputting anything here. So let's start it at 0, right? We'll see out the number here, number and an end line. Then I'm going to take my number plus plus, keep on going. It looks pretty similar to my while loop now, like almost identical. The only thing we've moved is where the while is, right? I don't think we've gained anything here because we had to start it at 0 anyway. Oh, I forgot we should, let's not even do that anyway. Let's do it with a do loop. Do loop. Where am I missing? Oh, I can't declare int number a second time here. Here's my do loop number. Now, if you want to change the name of something here, I've already used it a bunch of times. I don't want to change it everywhere. So I'm just going to do like my do number here. I'm just going to double click to highlight the whole word here. Triple click will highlight your entire line here. Double clicks highlights one word. And I'm going to go copy paste with some more double clicks, right? Just to make my life a little easier. That'll hopefully take care of that error here. Yeah, okay. Hey, we did it with a for loop. We did it with a while loop. We did it with a do loop. 3 different ways to do the exact same thing here. That's pretty much the rule in programming. Anything you want to do, you can do multiple ways, right? A lot of this comes down to what do you like? What's preference here? There's a lot of art that goes into software here. Um, as you get further along here, I'm sure they're going to pitch you, hey, you should continue school and get a master's degree because we want your tuition money, right? Which you can learn more cool things with a master's degree. That's why I went and got a master's because I was a school junkie. And there's lots of fun things to learn. But one of the programs we offer is a whole degree in human computer interaction, which is super cool. The study of like user experience, user design, human computer interaction. There are good scientific ways for computers and humans to interact. At this level, I could care less. It doesn't have to be pretty. I don't care. It's fine, right? But let's just acknowledge there are good ways to do things here, and there's bad ways to do things. Okay, not the end of the world. So we don't need to aim for the, hey, here's the the most scientifically proven. I'm going to give you the prompts here with the right font and the right sizings and bold things here. And it's crazy. Like humans are weird. You can look at a website and within less than a second you've decided whether or not you think it's a good website or not just by its visual appeal, and that colors your entire experience with the website here on out. So you go to some website and it looks ugly or it loads slow, you're like, oh, this thing is trash, even if it's the best application out there. You're not going to want to use it, right? People are weird like that. So, all right. So a basic for loop initializes something, tests, and has its increment. Yeah. Sorry,
Um,
just holler at me.
so if we write less code but it does the same thing, is the memory allocated, is that still gonna be the same or less?
Um, so in terms of how much memory is allocated, it's not based on the lines of code, but how many variables we're using. So if you've got 7 different variables when you could have stored it in one, you're using a little bit more memory. Now, our variables take up very, very, very little bits of memory here. So unless you're doing something a million times or a billion times, it makes no difference at all. Eventually, we'll look at how we optimize, and that's a bit more of the science things in computer science, optimizing problems. And thankfully, there's smart people who've studied these sorts of things. Um, yeah, so eventually we'll get to the optimizing. Um, for now, we're spoiled, and we just want to solve problems and practice the problem solving. How do we get code to solve problems for us? Eventually, we'll figure out how we make them fast. But yeah, nothing in this class worries about speed or efficiency. Um, a little bit in CIS 200, and then CIS 350 gets into a lot of the algorithm design. How do you make algorithms fast? That's the very exciting and fun class everyone loves. Um, yeah, it's great. Um, and I'm glad people study that stuff and are into that sort of thing here. But again, I like to make computers go beep boop bop. Um, other people make that fast, and I just get to tell the computer what to do. So I'm a little spoiled. Now that's the fun thing. There's lots of different fields in computer science, lots of different specialties here. Uh, all right, so this for loop here, right, starts a number, tests the number, increments the number. Now we can put a loop inside of a loop here if we wanted, right? So if I wanted to do something like print out a rectangle. Now, you all remember ASCII art? You can make a picture out of a bunch of characters here. We're going to do shapes because that's super exciting here. That's about as good as I get. I'm not much of an artist, but I can do shapes. So if you wanted to print a rectangle, here I'm going to say for int. Now this will be my row starts at, we can even start at 1. It doesn't really matter. Row 1, my row is, and I'll go less than or equal to 10. If I want to have 10 rows, right? I can go 1 to 10. I could go 0 to 9. This gives me 10. This also gives me 10. It's really just a preference here for you here. And then row plus plus, plus plus. Now for every row, I want to print out a certain number of stars, right? So I can say for int column is 1, column is less than, I don't know, let's go 4 maybe here, less than or equal to 4, and then column plus plus. I'm going to see out a single star character here. Now I don't want an end line because I don't want to go down a line until I've printed out every column. Once I've printed out every column, then I want to see out that end line here. So this will print 4 stars and it'll print an end line. Then it goes back and says, okay, row, go to row 2. Row 2 says, okay, column starts at 1, print 4 stars, and then print an end line. Row number 3, print 4 stars, end line, row number 4, right? On and on and on. So for every time the outer loop runs, the inner loop runs from start to finish here. So it's a loop inside of a loop. Now, this is a fixed number of times because it's my for loop, right? It's not like my while loop inside of a while loop here that checks your guess here, right? That was a loop inside of a loop, but this is also a loop inside of a loop here. So now I'll get a nice little 10 by 4 rectangle here, and we've made art. It's art class now, right? Or we can make these variable, right? We could ask the user. So we have a int for rows, or this should be like max rows, or I don't know. We can just go with rows. That's fine. We'll see out how many rows do you want, and then we can see in on rows. Now my loop now, instead of being less than or equal to 10, will be less than or equal to rows, right? A variable that these are entered. Right? And we can do the same with columns. So I'm just going to copy paste here and then do columns with an S here. Int columns, how many columns with an S? Make sure you don't forget your plurals here. Copy pasting puts you at risk of using the same variable name when you don't mean to. Just be careful. Oops, I forgot to change it here by 4. So, man, it was always going to be 4. So one more time, let's do less than columns now. Right. So now we should be able to ask, how many rows do you want for your rectangle? Fine friends. 5? Okay, and how many columns do we want? 5. We now have a square. All right, 5 by 5, which all squares are rectangles, right? Thanks to math. Fun like that. Cool. Um, we did a rectangle, or we did a rectangle. What about a triangle? Can we do a triangle? I'm going to do a right angle triangle because that makes my life easier. So I'm going to have like a star and then 2 stars and then 3 stars like that, right? A nice little right angle triangle. That's probably pretty easy here. Now, with that, all I need to know is the height or the base, right? They should be the same, right? So let's just ask them here then. We'll have an int for height, maybe. And then we can see out, enter the height of a triangle, end line, and then we can see in on height. Now I'm going to spit out just a couple end lines here just to add a little separator. Probably 2 is enough here because I want the triangle not to touch the rectangle. Otherwise it gets hard to visualize it, that's all. Um, so now I'm going to do something here. So for int, again, I want rows and I want columns here, but I want it to be a little bit different. So rows are fine, but how many stars do I want in each row? Well, the first one I want 1 star, the next one I want 2 stars, the next one I want 3 stars and 4 stars and 5 stars, right? So the rows will be less than or equal to height. Now my column is going to be less than or equal to row, right? At row 1, I want 1 star. At row 2, I want 2 stars. At row 3, I want 3 stars. Row 4, I want 4 stars, right? So my loop then will run a number of times based on whatever row it's on. So the values you can use aren't limited to something the user entered or a hard-coded number. It could be based on another loop value. It gets a little weird. I've done this before. Don't be super amazed that I've noticed that pattern of stars to rows. Like we do this example every semester, right? But let's try it. Right, rows, I don't know, 5 by 5. All right, how about the height of a triangle?
5.
I heard 6 first. Right, 1 star, 2 stars, 3 stars, 4 stars, 5 stars, 6 stars. We now have a nice little right angle triangle. Awesome. We missed yesterday was Pythagoras's day, right? It was 9, 16, 25, right? 3 squared, 4 squared, 5 squared in 2025, which is 45 squared. You guys don't like math enough, do you? I feel like you have to kind of like math a little bit because you got to get through a bunch of calculus. And if you don't like math, that's just miserable. All right, sorry. That's okay. Um, oh, I should mention, because I'm thinking of it now, and this is 150 here. Um, at some point, if you want to do an internship, some companies are stupid and they filter out internship applications based on GPA. GPA is just one number and it doesn't really measure a whole lot of stuff. And actually, we have research that shows it's not even a good indicator of job success, but yet they do it anyway because they're big companies and they can do whatever they want. I mean, they need some sort of filter, I suppose, if 100 people apply for an internship. So, sure, whatever. Um, but if your GPA is used to filter you out for an internship and you don't like math, don't take calculus here. If you don't do well at math and you just get by with C's, that's okay. C's pass. That C's get degrees. Perfectly okay. Like don't feel bad if you get C's. But if you don't take the calculus here, if you take it just across the street over at Henry Ford, it passes in transfer credit, not GPA. So you can get a C over at Henry Ford and it doesn't affect your GPA here at Dearborn.
I got C's in both my calculus, and I have like a 3.95 GPA here because I
Yeah,
transferred.
you transferred it over.
Yeah.
See, this guy over here is smart. Listen to this guy. Now, of course, we want your tuition money. You should definitely take your classes here. And obviously, we're better than Henry Ford College because, geez, they're a community college, right? We're U of M. We must be better. Okay, whatever. My full-time job is over at Oakland Community College, so I can make fun of community colleges, right? Is that okay? All right. Um, so that's your pro tip. If you don't like math, which seemed like a lot of you didn't, it's a little bit sad. Math is fun. Um, you don't actually use a lot of calculus. Depending on what you're doing in computer science, you don't need the calculus. Some branches and some specialties use a lot of calculus. Um, as a software developer who did software engineering stuff, I never used it here. I didn't actually take calculus till I wanted to get into the doctoral program here. So that's fine. I had a buddy who dual majored in math and computer science. He's like, it's only 4 more math classes to get another major. Why not get a dual major? And he's like, I never used any of that math ever again. So, but my brother's buddy got a whole master's degree and went to work for AutoCAD, and his master's was in how do you draw efficient curves. And he did a load of math to make curves draw quickly on computers. And that's why we have cool AutoCAD software that does curves really nicely. So, if you like math, there's opportunities for it. If you don't, go take it at the community college. Okay? Man, I'm on recording saying that. That's okay. That's fine. I'm thoroughly convinced no one here at the school watches my YouTube channel. And hopefully the students do, but no other faculty watches. Why? It'd be so boring. Like I would not want to sit through someone else's class. That sounds terribly dull. So, all right. So we did 4 loops. We did a loop inside of a loop. Um, we can do all sorts of fun things with these. How about we make an equilateral triangle, right? That has something like a star, and then we'll do 3 stars, and then we'll do 5 stars. I can't line this up right here. 5 stars, and then we'll do 7 stars. Right? Can we do something like that? A nice little equilateral triangle? Okay. Now, for us to do that, we need to figure out a couple things, right? When we print here, we print from the left 1 character at a time, right? So what's being actually printed on this first row here is a couple spaces and then a star. And then a couple spaces and a star, a couple spaces and a star here. So if we took a look at this real quick and like wanted to sketch it out on paper here or on the whiteboard behind me, we could do that. Now I'm just going to type it on my computer because that's a little bit faster here. But we'll say, hey, at row 1, right? How many spaces do we have? 1, 2, 3. I see 3 spaces, right? Spaces and 1 star, right? At row 2, how many spaces do we have? 1, 2 spaces. 2, and how many stars? 3 stars. Stars, I guess 1 stars. Oh my goodness, that looks terrible. That's fine. Row 3, how many spaces do we have?
One.
1. Okay, and how many stars do we have?
That's fine.
5 stars. All right, and then at row 4, how many spaces do we have?
Zero.
0. And how many stars do we have?
Seven.
7 stars. Okay. Now, if you were to imagine this was just a 3-star pyramid, it has 2 rows. A 5-star pyramid has 3 rows. A 7-star pyramid has 4 rows. If we wanted a 9-star pyramid, so row 5, how many? Oh, our spaces have to change here. But we'd have 9 stars, right? We'd see that pattern going. So what we need to do then is find out what's the relation between how many stars we have at the base and how many rows we have and how many spaces we have. So there's some quick arithmetic we can do with looking at 7 stars has 4 rows, 5 stars has 3 rows, 3 stars has 2 rows here. It's okay if you don't see the pattern right away. I've done this a gazillion times here, but think about it for a second here. Do we see any sort of pattern, any sort of arithmetic we could do? You get from 7 to 4, 5 to 3, 3 to 2. Right? And we'll just continue on here. Ignore the spaces for a minute here. So row 5 then would have 9 stars, right? Row 6 would have 11 stars, right? So how do we get from 11 to 6, 9 to 5, 7 to 4? What's that look like?
You add the row numbers with the increment of 1, 2, 3, 4. So row 1 gets plus 0, row 2 gets plus 1, row 3 gets plus 0.
Okay. That sounds trickier than what I was thinking, but definitely workable. I think we could work with that. So you start adding an additional 1 for every next row. Is that what you're saying? Okay. Um, so we would have to count up to the number of rows rather than like if we would ask how many stars do you want, and we would calculate the rows from there. We'd have to do some counting up. I think we can make that work. I think there's an easier way. Actually, I know there's an easier way, but we could try that if we wanted. Or do you want to keep thinking about the easy way? All right, well, then keep thinking about it. We keep looking at the pattern. Row 7 is 13 stars. Row 8 has 15 stars. Yeah.
Are you asking us to find the pattern?
What's the relation between the two? How can we calculate rows from stars or stars from rows?
It's like the stars be like the last 2 rows added together. Like 15 is 8 plus 7. That's another 7, so it's 9 plus 8.
Okay, definitely workable. Okay, you guys are coming up with stuff I haven't thought of, which is really cool. Yeah,
Times 2 minus
times 2 minus 1. That's what I was looking for. That's the easy thing, right? Finding the previous 2 added together, definitely doable. Sounds a lot harder to have to write code for. So times 2 minus 1. Now the problem is we're going to ask them for how many stars they want, so we need to reverse that. So what's the opposite of times 2 minus 1? Divided by 2 plus 1. And we want integer division. We want to floor that division, right? We don't want halves here, right? So 15 divided by 2, 7.5. We just want 7 plus 1. 13 divided by 2, 6.5. 6 plus 1, right? That's what I was looking for. That's what I imagine is the easiest one here. So if we ask them how many stars they want, then so we have an int for stars, and we see out how many stars in your base here. I don't know, something like that. Sure. And an inline, goodness, and then we see in stars. And then we can calculate rows then. So in rows then will equal my stars divided by 2 plus 1. Right? Integer divided by integer, we get an integer result. We don't have to worry about decimal places. Plus 1. We're good to go with our number of rows. Okay? Now, the next tricky part here. How do we get from the total number of rows to how many spaces we need? Right? So let's just look at this example here, right? If we had 4 rows, how many spaces did we have? Well, so how many spaces do we start with? 3. So if we were to pretend this was one higher here, 2, 1, and then row 5 would have 0 spaces and 9 stars, right? 5 to 4 do we see a pattern? We had 5 and 4, we had 4 and 3, minus 1. Okay, yeah, so easy. So then I int for spaces, then starts at my rows minus 1, right? So now I have all the information I need to print this out here. And then we also start with 1 star. This pattern was easy. I didn't even ask you here, right? So int per stars. Oops, that's total stars. Maybe we'll call this, you want like base? We'll call that base. Base then. So base divided by 2, and then stars just starts at 1, right? And what we want to do, so for int row equals 1, row is less than rows, row plus plus, right? This will be how many rows we're doing here, right? And then we need to print out the right number of spaces then. So for int space is 0, or space is 1, I guess, right? Space is less than or equal to space is here, space plus plus. Let's see out a space. No end lines, right? Just this number of spaces, right? After I've printed out my spaces, now we can print out our stars. So for int stars 1, stars less than stars here, right? Star plus plus, we'll see out a star for every number of stars we're supposed to print out here. When that's done, then I want an end line, right? Go down a line. Okay. Now, what happens to our number of spaces and number of stars? What happened? Spaces should go down 1, and stars should go plus equal 2. Our little combined assignment operator. We love shortcuts here, right? That's the same as stars plus equals stars plus 2. Remember that one? Okay, cool. Right, that's just our shortcut. So this is minus. We don't decrement all that often, but we can. We can decrement, right? So should we try it? Oh, I got to copy in some end lines here too. Let's separate our triangles here. All right. Oh no. Int rows. Oh, I redefined rows. Goodness. All right, that's fine. So we don't need to tell it it's int rows here because we already have used rows up above. We just can say, let's reset the value of rows. Oh no. Oh, okay. My bad. I had left all those stars in here. All right, that was all the errors. Nice. All right. So I don't know how many we want for our rectangle. 6 by 4. Okay. There's a rectangle. How about our right angle triangle? 5. All right. Now, how many stars in our base for an equilateral triangle? 8. Hmm. If it's an even number, it doesn't work very well. We lost something here. So let's go fix that, right? Even numbers are bad, right? It has to be odd to start with 1, right? So let's go validate. Okay, why not? So how many stars in your base? Now, how can we test if a number's even or odd? Mod 2, perfect. So base mod 2 equals 0. It's even, right? Evens are bad, right? We want to say how many stars are in your base here. See out must be odd. Like Eric. Let's try it again. All right. Oh, 5 by 5 by 5. Sure. Stars in your base, we said 8. And we get must be odd. How many stars in your base? 9. Uh-oh. Still didn't print out right. Something's not working right. Okay, well let's find out what's happening here. So let's go here. Put a breakpoint in. See what's happening. 5 by 5 by 5 by 9. All right. So we get rows is 5, right? 1 star, 3 stars, 5 stars, 7 stars, 9 stars. That's good, right? Spaces should start at 4, right? 4 spaces, 1 star. Star starts at 1. Life is good so far. So rows less than 5. Good. Space less than spaces. We should have 4 spaces. 1, 2, 3, 4 spaces. We're done with that loop. You see my error here? We're about to run into it here. Star starts at 1. Star is less than stars. Print out a star. It didn't run. My test here wasn't true. This was false. I forgot my equal sign. Yep, less than or equal to here. So if it's not doing what we expect it to do, running it line by line by line will show us it skipped something that we thought was running, right? Obviously, I did that on purpose to demonstrate that for you here. That was not a typo on my part here. It happens all the time. Don't feel bad about it, right? Debugging your code, perfectly normal. There's nothing wrong with that at all here. So let's stop and give it a run again here. Let's try it again. So 5, 5, 5. All right, we'll try 9 stars. Oh, I'm going to continue here, right? That'll just run to the next breakpoint here. And now that looks a little bit better, right? 1, 3, 5, 7. Uh-oh, where's my last row? Do I have another typo here? Less than rows. I did it again. Less than or equal to number of rows. Goodness. Um, most of the time I don't use the equals here. Most of the time I do less than and I start at 0. My bad. It's just a habit here. I don't usually start at 1, but somehow we got into that example. Let's try it again. 5, 5, 5. 9 stars in our base. Continue. Oh, I can just take my breakpoint out too for next time. Continue. And does it look right? Hey, I think it looks right. A 9-star equilateral triangle. We've done art today in computer science. Congratulations. It's actually some really cool art stuff you can do with computer science, like fractals and other sorts of fun things. Really cool. Uh, that's fun stuff. How you feeling? That was a lot. A lot of loops. While loops, do loops, for loops. We got pre-test loops. We got post-test loops. Right? They can all do the exact same thing. So a lot of it's just a style preference here. If we know how many times a loop is going to run, we're going to use a for loop. Right? That's easy. Right? It just puts it all in the header there, the loop header, and then it runs. A little bit harder to do validation loops with for loops. You can, but it's kind of ugly. Right? We don't usually use for loops for validation loops, those sorts of things here. So we stop that. I got 12:11 on the clock. You want 4 minutes back and get out of here? Yeah.
Just a quick announcement that on that side we have got